Hello, hi everyone, welcome back to the channel. So this is your Ramandeep Singh. I'm back with yet another lead code problem. So in the previous days I was a little ill, that's why I couldn't upload video. But from now I will be uploading videos continuously. So in this video lecture we'll be solving this problem non-overlapping intervals, which is a medium tag problem. So this is one of the problems from the blind 75 list, and it is really important problems to practice. So we're given an interval array which is called intervals, where any integer in this intervals array, any element in this integer array is a pair start I and end I. We have to return the minimum number of intervals that we have to remove to make the rest of the intervals non-overlapping. So what does that mean? What is the meaning of non-overlapping intervals? So let's understand that. So we have intervals like 1 2 1 2 1 2. Then we have intervals like 2 3 2 3. Then the third interval is 3 4. It's 3 4. The next interval is 1 3. So these are the intervals that we are given. So what is the meaning of overlapping and non-overlapping intervals? So basically let's plot these intervals on a number line. So we have an interval 1, then we have 2, then we have 3, then we have 4. So these are the numbers. This is the number line. The first interval is this 1 to 2. The second interval is this 2 to 3. The third interval is this 3 to 4. And the final interval is this 1 to 3. So these are the intervals that we have, right? So what do we have to do here? What we have to do? Think about it. We have to remove the intervals which are not overlapping, right? Which are not overlapping. We have to return we can see that we need to remove the minimum number of intervals that we need to remove to make the rest of the intervals non-overlapping, right? So the rest of the intervals must be non-overlapping. So what do we have to do here? How can we do that? The intervals must be non-overlapping. So here we can see that we have 1 2, then we have 2 3, then we have 3 4, and finally we have 1 3. So we can see that these three intervals 1 2 2 3 3 4, they are non-overlapping, right? But there is a one interval which is 1 3 which is overlapping, which we have to remove, and that's all. The answer is 1. We have to remove one interval. So what do we have to do? Count the non-overlapping intervals. So let's say that count is C and T. This C and T stores the intervals which are non-overlapping. 1 2 2 3 3 4. N are the total number of intervals. The n minus C and T is going to give me the rest of the intervals, right? N minus C and T is going to give me the rest of the intervals. So we have n as 4. C and T is what is C and T? The C and T is 3. C and T represents the non-overlapping intervals. We have 1 2 3. Then we're going to return n minus C and T, that is 1. The answer would be 1, right? So that's all we have to do. Fine. So what we can do now? What we can do now? To solve this problem, what we have to do is we have to count. First we have to count the non-overlapping intervals, then we will be able to find the non-overlapping intervals, right? Because you can see that if we count these three intervals, we can simply subtract this 3 from n, right? And that is going to give me my answer, right? So how we can do that? Let's see. So to do so, what we have to do is we have to, here this is basically our screen. So here, for the second interval to be non-overlapping with the first interval, the starting of the second interval must be greater than or equal to the ending of the previous interval. That is the condition which we have to understand. Same goes for the third interval. The starting of the third interval should be greater than or equal to the ending of the previous interval. Fine. Same goes with the final interval. The starting of the final interval must be greater than or equal to the ending of the previous interval, which is not the case here. Which is not the case here. So V means this 2 2, this 3 3, these are 2 2 3 3. What are these? These are non-overlapping. So 2 2 3 3, and then we have 1 4, right? So what do we have to do here? We have to count these intervals. So we'll start from here. This is I. So this is I. So let's take I to be the second interval, and this is, let's call it previous. But before that, notice that to count these type of intervals, we have to sort them by the ending point. Why? So if we sort the intervals by the ending point, only in that case we will be having the intervals in increasing order, right? So imagine the scenario when we have this second interval before this interval. So we have 2 3 here. Now we cannot compare the second interval, which is this now, with this one. Why? Because this interval lies ahead of it. There's no meaning in comparing it, right? So that's why, to make the comparison easier, we have to sort them in the increasing order of the ending interval. So we'll sort them according to the increasing order of the second integer. So we'll have 1 2, we'll have 2 3, 3 4, 1 3, like this, right? Fine. So that's all we have to do. 1 2, 2 3, 3 4, 1 3. Fine. So let's start the I from this one, and previous let's keep here. Before that, we're going to sort them. So first sort these intervals, then keep an eye on the second interval, let's call it I, and after that let's start comparing. Compare the first integer of this interval with the second integer of the previous interval. If it is greater than equals to that one, that means we're good. Then move to this one. I is here. 3 is greater than equals to this 3. That's good. Move I to the next interval. This I, this first one, is not greater than equal to this one. That means we have a problem here. The count is 3. The count is 3. That means n is 4. So 4 minus 3 is going to give me 1. So the answer is 1. That means I have to remove exactly one interval to make my intervals non-overlapping, right? So the answer is 1. So that's all we have to do. So the solution is simple. Sort the intervals by the second integer, right? Then keep a count and keep another variable. Start comparing the intervals with the previous interval, right? The previous interval is the one where the ending point is less than or equal to the starting point of the current interval, right? And let's better understand it with one more example. So let's take the second example which we have for this problem. The second example is 1 2 1 2 1 2, right? The second example is 1 2 1 2 1 2. That means what we have here, we have 1 2 1 2 1 2. So here this is the first interval. Let's call it, let's say we have C and we have previous here, PREV, and then we have I here, right? So here we can see that 1 2 is this one. This 1 2, the starting, they are already sorted by the second integer. So the starting point of this integer is greater than equal to the ending point of the previous interval. Here the starting point of this interval is, okay, we can see that the starting point of this interval is less than equal to the ending point of this interval. That means we have a problem. We have a problem. That means we do not have to count. We do not have to count here. We simply move I to the next interval. That means this is invalid. I simply mark it as invalid. Fine. Move I here. We can see that this starting point of this interval is again not greater than equal to this one. Mark this again and invalid. So I is here. That's all. Previous is here. Right? So what is count? What does the count stores at this point? What does the count stores at this point? the count was 1 initially, right? So we can see that this count represents the number of valid intervals, right? The number of non-overlapping intervals. But we can see that we do not have any non-overlapping interval, right? So that means this count is 1, because one interval is always non-overlapping. We neither incremented count here nor we incremented count here. So the count is still 1. So that means n is 3, the total intervals, minus the number of non-overlapping intervals, which is 1. That means 2 are the number of intervals which are overlapping, which is indeed the case. If we plot the things on the number line, we have 1, we have 2. So the first interval is this, the second interval is this, the third interval is this, like this. Fine. So the answer is 2. So let's jump to the code implementation part. So here we can see that let's take n is equals to intervals dot size, then let's sort them. First let's create a static bool vector of b return a of 1 greater than b of 1. Why? Because we are sorting them by the second integer, so that's why we're comparing the second integer, right? So we're going to sort intervals dot size, intervals, it's not intervals dot size, intervals dot begin, intervals dot end, right? Then after that what we have here is, let's take a count which is 1, let's take I which is, let's take a previous variable which is 0. Let's start from it. I is equals to 1, I less than n, I plus plus. We can see that if intervals I1 is greater than equal to intervals I0, that means increment the count by 1 and reinitialize previous to I. At the end, return n minus count. So what does that mean? We have the size of the intervals, we have to sort them, and we also have to pass the comparison operator, CUMP, right? And here we have count, and then we have to just do these things, right? Intervals I1 greater than equals to intervals I0, count plus plus, previous of I, and minus count, right? So in this fashion, what we are getting is, we're simply getting the number of non-overlapping intervals. We're simply getting the minimum number of intervals that we have to remove to make the rest of the intervals non-overlapping. So these many intervals I have to remove to make the rest of the intervals to be non-overlapping. So let's run this one. Okay, it's giving me wrong answer. I'm doing something wrong here. Okay, this is not I1. This is, I have to compare the first one, the first integer of the current interval with the second integer of the previous interval, right? Like this. So let's run it. Okay, so again giving me a wrong answer. Let's try to submit it. Okay, that got accepted. So that's all I have to do, and this was a not so hard problem, it was a medium tank problem. So stay tuned with me, make sure to subscribe to the channel, and I will keep coming up with such videos in the future. So I will see you soon in my next video. Till then, take care. Bye bye.